there is almost no change in the color, which means when you paint a house with this material, it will remain white, it will remain brown, it will remain pink if you want it. It will not change the color. Now this is a huge saving on an economy, because you know what? We have to paint our houses, if we can force that, every 2 to 3 years. Using this technology, which is expected to last over 25 years, you will not need to paint your house before 25 years, and it will remain clean. What is more important is that this technology actually results in a pollution control, because they are using titanium dioxide in this material. And titanium dioxide, using the light, is able to break carbon dioxide, carbon monoxide, and break nitrogen monoxide. And using it would actually result in a 40% decrease in pollution. So not only that we will have our cities looking clean, but we're actually going to control the pollution that is happening from the cars. Another area for engineers that would be interested, this is actually concrete. This is transparent concrete. Okay, this is not a مش ستارة ولا it's not مسلح. And what you can see here, it's transparent concrete. Well, a lot of you will be saying, well, okay, fine, nice and dandy. What are we going to do is that? Well, think of a place like this. Instead of putting all this light to keep it lit up, having transparent concrete like this will enable enough light to get through that you will be saving on your energy. Another area is insulation. And again, what I'm trying to show you here is that areas where this technology has a cross implication. It's not just for construction. It's also for the engineers who are designing the house. It's also for the people who are designing the electric circuits. What you see here, this is actually a 5-ton piece of rock. I don't know if you're able to see it, but there is a material down here. It's actually called aerogel. This material is 98% air, and the rest is just polymer. Now, this material was originally developed by NASA for heat insulation, and here's an example of what it can do. As you can see, it's very simple. What we're going to do here is that we're going to put a flame on this part. It's showing that it is flexible. This is compared to other fiberglass, for example, here. And what we're going to do is that we're going to put a flame down there. The flame should be reaching a temperature of about 1,000 degrees at one point. The thickness of this insulation is 6 millimeters. 6 millimeters. The temperature on the other side is 100 degrees. So by 6 millimeters of this material, we are able to cut down 900 degrees of temperature. Now again, using this in a house would result in huge energy savings. And by the way, this is also looking at minus 87 degrees, and it's 22 degrees outside. And again, this is 6 millimeters. Alright? The advantage of these materials is that they are so thin that you can even paint them on your different applications. And this is an example here. This is a boiler. If you put your hand on this boiler from the outside before the using of this material, the temperature was 160 degrees. If you paint it with this material, which is 2 millimeters thick, the temperature is 60 degrees. This has a huge implications for energy savings, has huge implications for different industries, because a lot of the energy wasted in the industry is because of heat loss. Even in electric engineering, you want to insulate and isolate. You want to do both of things because your wires will eventually heat, or you want to prevent them from melting in a high temperature application. This is the road, so we'll go through it. So I've shown you application in construction. Now we're going to jump into textiles very fast. I'm not going to look at this, I'm just going to show you this. Now this is a red dye on a suit. This suit is made of wool, souf. Okay? And as you can see, I'm sorry to have to tell you that this is, the material they've put there is red wine. Why they do that? Because red wine, when it stains, there's nothing you can take it out with. The shirt is destroyed. The pigments in the red wine are very, very strong. And what you can see here, I'm going to play it once more, is that this is the souf. 100% souf. And nothing can stick on it. Now, this is a very nice application for business people, for, it's fine. If you can pay for it, it's fine. It's not that expensive, by the way. But think of this application. This is one of the very clear examples when I say a global idea, a global innovation, and you take it and you tailor it for a local solution. Now take this same application. By the way, the cost of doing this is 10% of the price of your material. To make it like this. If you have a sheet of لو في قميص القميص ده ب 50 جنيه عشان تعمله كده هيكلفك 55 جنيه يبقى ب 55 جنيه. Okay? That is the cost. And actually these are applications that you can find nowadays in the market. Now take this idea and take it as it is and apply it to the hospitals, to the blankets of the hospitals, where a lot of disease has been transmitted because the blankets in the hospitals are not being cleaned fast enough, are not cleaned regularly enough. This will stop the transmission of different diseases. It won't stop it, it will lower it at least. Because using this technology, you're able to do something to stop the transmission of diseases through the liquids and the blood that soak into the blankets. Now a lot of people will be asking, so how much does it cost? And I actually said, these are 3 different examples. We're looking at different things. We're looking at tennis balls as a luxury example. And the price between a normal tennis ball up to a nano innovation tennis ball, you pay an extra 42%. If you look at medical application from traditional to a nano-enabled, there is a difference between nano-enabled and a nano-innovation. A nano-enabled is actually where you modify the application that you have. Nano-innovation is when you completely change the game. Nano-enabled medical application, the price premium is 15%. This is textiles. The price premium from this to this is 11%. From here to here is 15%. Okay, so it's not that expensive. Now what can we do? What must we do? We have to look at, identify market transitions. We have to look at the very clear vision. We have to know what we want to do. We have to look at specific areas that we need to work in and push all our resources in it. And this is something for you as students that you have to think about. You have to think about, where can I work in this area? What is the most possible application that will have a big impact on our society? So what we are suggesting that there should be a national nano initiative, and it would be actually, this is a very fast map of what needs to be done, the awareness, the production and the investment, and how can the different areas, whether it is the government, the industry or the public, the different investors should be working together to reduce these things. So nanotechnology has a very big equalizer effect, because the number of applications that you can do between different industries just makes the amount of solution infinite. When you have an engineer, when you have a chemist, when you have a physicist, when you have a biologist and a medical doctor working in the same research group, the amount of solutions that you can come up with is so great. So what have we been doing in the past year and a half? One of the things we're doing, we have a program called InterNano, and this is actually for high school kids, age 14 to 18. And it's teaching them what nanotechnology is. And this is actually a program that is funded by the European Union. We have oil and gas, which is a conference taking place next November in Cairo, looking at applications of oil and gas, nanotechnology in oil and gas. Nanotech Business Summit, which is looking at different applications and different business opportunities for nanotechnology in the Middle East and Africa. This is a fundamental research conference that has been running since 2005. This year, 2009, it was in Barcelona. In 2011, it's back in Cairo. Nano construction, which took place last May, and it's again going to be next year in May in Cairo. And these are the areas that we are looking and interested in. Nano health, renewable energy, nano application for agriculture, nano application in aqua and water, and Nano Bridge is a meeting looking at what are the different areas that a developing country needs to work in. And in conclusion, I would like to draw your attention that the time to act is now. In this presentation, I have not shown you some of the examples where students as young as 14 years old, 14, have done scientific contribution in nanotechnology that has been recognized worldwide.